Welcome back to College Algebra MAT 150. In this lecture, we will discuss the forms of equations of lines. So, there are three main types of equations of lines that we will see. In fact, we've seen the first two. So, the standard form, where you see ax plus by equals c. We saw that in at the end of section 1.3, part 4. Where we had to actually turn this standard equation into slope-intercept, which is another one which is one we've 100% talked about, y equals mx plus b, with m being the slope and the y-intercept is given by 0b, where b is the b in the y coordinate is from there. But there's this third one, and it's called point-slope form of an equation of a line. And this one's kind of strange. And you'd be like, well, why are we introducing a new one? And we will explain why here soon. But it's given by y minus b equals m times x minus a, where m is still the slope, but then ab, so this b doesn't represent the y coordinate of the slope intercept of the y intercept, but it's just b is part of a y coordinate of a point, a general point where you have something else a. So why is this useful? Well, so as a reminder, so the point slope form shows two things. It says this AB is this point, and so AB is a point, and it has slope. And what are the two things we need to make to graph an equation of a line? Well, it turns out it's the same things that we need to make an equation of a line. We need a point and a slope, or we need 2 points. So remember, once you have 2 points, that's how you just make the graph of a line. Or if you have a point and a slope, you can use the point and then get another, you can graph the point and then use the slope to get another point and then graph it that way. So in finding the equation of a line, it's similar in that sense to finding the graph of a line. And so why is point slope important? Because it's easier to find the equation of a line with point slope than it is the other two. For example, especially if you don't have an equation already. So for example, if I just said, hey, I have a line that has a slope of 2/5 and it passes through this point 3, 1, all we have to do is look at the point slope form of an equation of a line, y minus b equals m times x minus a. We have a slope of 2/5 and have a point AB given by 3, 1. Literally plug in 1 here, so y minus 1 equals 2/5 x minus 3. Is this an equation, because there's an equal sign? Yes. Of a line? Yes. We're done. That's it. So again, that's why it's very, very nice to use point slope, because when you're trying to find the equation of a line, you just need that. So what about if we have a line that is determined by the points 1, -2 and -3, 4? Well, what we can do is here we don't have a slope, but we have 2 points. All right? Well, we need slope to use point slope, so let's do that. Let's find that. So slope between 2 points, you have to do the change in y over change in x. As I've shown before, my recommendation is to first actually pick 1 point, it doesn't matter, put the y over the x. So I'm going to take this first one I come up to, -2 over the 1. And then I have -3 and 4. I'm going to put minus, minus, and then parentheses, parentheses. That'll make sense why here in a second. I put the y over the x again. I was cautious in this time to put parentheses here, because we have a minus a negative down here. And when you're subtracting a negative, that becomes positive. So in the top we have -2 minus 4, which is -6, over 1 plus 3, which is 4, and which gives us -6/4, which we can simplify to -3/2. So now we have a slope, We have 2 points, we just need one of them. So that means we can use the point slope form. So of an equation of a line. So that's given by y minus b equals m times x minus a. And as it turns out, it does not matter which point you use to plug in for a and b, as long as you're using, well, the same point, the x and y from the same point. So I'm just going to use the one with simpler numbers. So we have y minus, again, when you deal with the negatives, I usually, and I'm plugging in a negative, I put parentheses just for extra clarification. So y minus the y coordinate here is -2, so minus a negative, equals -3/2 x minus, here it's 1, so I'll just put 1 in right away. A double negative is a positive. Y plus 2 equals -3/2 times x minus 1. Is this an equation of a line? Yes, it is. So unless the problem actually tells you to put it into slope-intercept form, this is a perfectly acceptable way. All right. What about if we're given this question? The line has a slope of 1/4 and a y-intercept of 0, 2. Well, in this case, yes, just going ahead and using the slope-intercept form is probably better because we do actually have the y-intercept. So y equals mx plus b. That's the slope-intercept form of the equation of a line. Y equals 1/4 x, and the b is the y-coordinate from the y-intercept. So again, this has to be 0 to be able to use it. The x-coordinate does. You get this. And you're done. That concludes everything from section 1.4, part 1.